Everybody has 7.3 notes open? All right, so 7.3, we're going to learn about logarithmic functions and how they relate to our exponential functions that we've been dealing with. So a logarithm has a base b of a positive number x satisfies the following definition. So we have this equation here, log base b of x is equal to y. And we can change this to look like this one, b to the power of y is equal to x. So this is logarithmic form, this is exponential form. And we can go back and forth between the two. And then problems with that log in it, we read it out loud this way. We would say log base b, so that little number down low is our base, of x. So log base b of x is equal to y. So here's another example of us putting it from exponential form to logarithmic form. So whatever the base is, stays your base, and you just switch the positions of the other two. And that base either is attached to the log or it has the exponent. So the base is like the special one that's either attached to the log or it has the exponent. On the next page, we're just rewriting each into logarithmic form. So it gives us a bunch of exponential. We got to put it in log. So every time we see logarithmic form, it has to have that word log in it. So all of these are going to start with log. Now log, what's our base going to be? 3. So log base 3, and then we switch the position of 5 and 243. So what comes next? So 5 would come next, but now we're putting the 243 in front. So 243, and that's equal to 5. So if it helps to write it right underneath, and write it down here. Log base 3, because the base stays as our base, and then 243 comes next, and it's equal to 5. Let's look at the next one. We have log, what's our base? 25, and then what comes next? 5, and then that's equal to what? 1/2. Awesome. So log base 25 of 5 is equal to 1/2. Let's look at the next one. What's our base?
10.
10. And then what comes next?
10,000 and then 4.
10,000, and it's equal to 4. So log base 10 of 10,000 is equal to 4. All right, next one. What's our base? 6. And then what comes next?
1/6.
1/6. And then what's that equal to?
-1.
Equal to -1. Perfect. And then the last one. What's our base?
A.
A. What comes next?
C.
C. And what's that equal to?
B.
B. Awesome. Good job, guys. So on this page, we're taking it from logarithmic form and putting it into exponential form. So all of our equations here are going to have exponents. So our base is what's touching the log, so that's our base. And then we just switch the next two numbers. So next we have 1 as our exponent, and then that's equal to 9. So in the second one, what's our base? 2. What's our exponent? 9. And then what's that equal to? 512. Awesome. Number 3, what's our base? 8. What's our exponent? 1 over 3, and then what's that equal to? 2. So if we wrote it down here right below, we have 8, that's our base, that stays there. We have to switch the 1 over 3 and the 2, so 1 over 3 goes here, and that's equal to 2. So again, if it helps you, just write it right below it. That way you can see you're just switching the second two numbers. In the fourth one, what's our base? 4. What's our exponent? -2. And what's that equal to? 1 over 16. And then the last one, what's our base? B. What's our exponent? 0. And what's that equal to? 1. Good job, guys. Any questions on this page? Is that all we're going to have to do? Oh, no, I didn't. All right, so oops, I skipped a page. So here we're solving. So we're applying what we just did to help us solve this. If we don't know what the log base 2 of 16 is, like, yeah, we could put it in our calculator and figure it out, but right off of our head, we don't know what it is. It's going to be equal to some number that we can call x. We can solve this in exponential form because we know what exponents are. We can evaluate exponents. So let's change this to exponential form. So what's our base? 2. What's our exponent? Switch these. What's our exponent? X. And what's that equal to? 16. So 2 to what power gives us 16? Let's see. What's 2 times 2 times 2 times 2? So 2 to the 4th power is what we're testing. 2 times 2 is 4, times 2 is 8, times 2 is 16. So yep, 2 to the 4th power. So what's x equal to? 4. Perfect. And that's it. Yes. All right, so let's look at the one right below it. So this is going to be equal to some number which we can call x. So what's our base? 8. What's our exponent? X. And then what's that equal to? 8. So 8 to what power gives us 8? 1. So what's x equal to? 1. Awesome. All right, the next one. What's our base? 49. What's our exponent? X. And what's that equal to? 7. So 49 to what power gives us 7? This one's a little bit tricky because 49 is bigger than 7. What'd you say? Ah, awesome. X is equal to 1/2. Because if we took the square root, which is the same thing as the exponent of 1/2, that would give us 7. So x is equal to 1/2. Because, so let's say if we had x, the square root of x, that's equal to x to the 1/2 power. So we're saying 49 to the 1/2 power is the square root of 49. And what's the square root of 49? 7. So that's why our exponent is 1/2. Good job, Segi. All right, last one. What's this is equal to x. We need to find what x is. What's our base? 2. What's our exponent? X. And then what's that equal to? 2 to the 5th power. So 2 to what power is equal to 2 to the 5th power? 2 to the 5th power. So what's x equal to? Well, what is just x?
Oh, 5.
5. Perfect. So if your bases are the same, we have 2 and 2. That means x is equal to 5.